In this lesson, we're going to look at another simple sorting algorithm called the insertion sort. The insertion sort works by essentially splitting the array or the collection up into two parts. The first part is the array as sorted, and the second part is the array as unsorted. So with two parts of an array, the second part is the part that's unsorted. Its elements are inserted into the correct position in the sorted array, which is the first part. That'll make more sense once we see examples of the array being sorted. So let's go ahead and get started. Again, it's called insertion sort, so that will be our name. First thing we do is create a couple of variables, j and temp. We'll show you how those are used in a moment. Then we begin a loop, starting at the first element of the array through the size, or one less than the size. And then in the loop, the first thing we do is we set the variable j equal to whatever the current value of I is. And then here's the second part. So then we have a while loop that says while the value of j is greater than 0 and the value of the array j minus 1 position is greater than the array jth position, then what we want to do is swap those values. In other words, we're trying to get smaller values to the left and larger values to the right. The scheme of lots of sorting algorithms, especially the simple ones. So this is just a simple swapping piece of code. Then we decrement j by 1. Close off the while, close off the for, and close off the function. And we're ready to go. So let's write some code to sort. And we'll do a 10-item array again. We'll call it numbers. Rolled up for you. Seed our random number generator. Then write our loop to create the array. Here we generate a random number. Then we display it just so we can see our original array before it's sorted. Add an extra new line to that. Call the insertion sort function, and then use our display function at the end to display the result. So let's build and run the project. And you'll see that it indeed sorted the 10 items into order from 27 up to 98. We can watch how it works by adding the display function into the insertion sort function at the right place, which is usually after the inner loop and before the next iteration of the outer loop. And there you can see the results of sorting this array. Notice how 1 automatically got moved to the left and values are trickling down. Notice how 91 is slowly moving to the right, 7 is moving to the left, and that's how it works. Larger numbers go to the right, smaller numbers move to the left. Let's look at one more instance. Notice how 4 takes it a couple of iterations. And actually that's because 34 and 54 are swapping positions, and 42, and it's working its way over, and then 8 moves over next. Takes 2 a while to get from the end to the beginning, but it eventually does. So once again, this is the insertion sort. It's a fairly easy algorithm to implement and works well for small data sets. However, for larger data sets, it becomes more inefficient. And so in the next couple of lessons, we're going to look at algorithms that should be used when you have large data sets. Certainly data sets larger than in the hundreds or even thousands of data items.